Here's some evidence of coastal Kelvin waves propagating along the coast of Australia. Okay, so the Australian continent is a large island, and these waves can only propagate around them. Okay, until they dissipate, or if they decay. And here are some examples. So what's shown here are time series of sea level whereby the tides have been removed. It's tidal residual sea level recorded every 6 minutes, and there are statistical methods by which you can remove tidal oscillation. So this is the non-tidal sea level at different locations, and the locations are marked, labeled on this map. Okay, I get the, let's see, here's the laser pointer. You can see there is a D is Darwin, then we have Broome, then we have Hillary's Esperance, Thevenard, Port Stanwick, and so on. We go all around, and you can see, and this is a time series. Time series in terms of days, okay, and this is July 1997. And you have each division, okay, is 1 day. You have 25, 30 days, and in the vertical you can see each division is 20 centimeters. And you can see an anomaly. There's one anomaly starting here on the southwest coast at Hillary's, and then you can see later a delay in Esperance, and it moves along the coast with the coast on its left. And these waves actually propagate at phase speeds of square root g times h. And you learned about square root g times h when you first studied gravity waves in the ocean. That's the speed. Again, there are two other events where you can see the same feature. Okay? So what the message here is that you can actually create coastal Kelvin waves, okay? And they can have an amplitude of 50 centimeters plus in Australia, on the west coast of Australia, big storm on the west coast, and then they travel along the coastline and can increase the sea level here in the Gulfs, and in Spencer Gulf, Gulf St. Vincent, by 0.5 meter. These are coastal Kelvin waves. And by the way, there are two different types of coastal Kelvin. One are called barotropic. They involve the entire water column. So everything moves in the same way, and they're very fast propagating waves, propagating at square root g times h. And then there are slower propagating internal Kelvin waves. And what they do is they actually, on their way, create a transient upwelling feature in the water column, okay, or a downwelling feature, and move slower along the coastline. So these waves are truly fascinating, and they actually create a teleconnection between different regions. All right.